Hi, my name is Dylan Eaton, and today I'm going to be talking about flow through porous media. So this is when you have a liquid or air or anything that can be calculated for flowing through media that isn't what we normally talk about. So it has like blocks in the flow, which typically for the calculations that we've performed so far are going to be uniform media throughout all. So with that, the Reynolds number formula now changes to account for the diameter of the particles in the flow in the media, as well as the efficiency of the flow through the media. And then you have the Ergun equation, which is calculating for the friction loss, which calculates for the friction loss in turbulent flow for here with the 150 coefficient, and for the 1.75 coefficient talks about laminar flow. And you can use both of these parts of the equation to calculate for like an in-between. So as far as conceptual questions go, what happens to the friction factor when the efficiency is increased? The coefficient for the velocity decreases with increasing efficiency. This makes sense, as the easier it is for a fluid to flow through the media, the less friction force there is acting on the fluid. And how does the particle diameter affect the Reynolds number, and what does this mean? So larger particle diameter leads to a greater Reynolds number, but the Reynolds number is highly subject to the viscosity of the liquid flowing through. A high Reynolds number determines whether the flow through the media will be turbulent or laminar.